Here's my 2000 VW Jetta. Today's problem, the wipers will not shut off. Can we fix it? Let's find out. Now to start this job, remove a 20 amp fuse at this position. I think it's position 24. If I'm wrong, I'll note it later. And you just pop it right out from here. Now we remove this fuse to disconnect power to the relay that we think is responsible for this problem. So with no power there, we can't really damage anything when we yank it out. Now you'll need to remove these covers. First you want to pry off the cover that's here, and then there's, count them, there's 3 screws holding the lower panel on. So you take out these 3 screws, you drop these panels, and now we have access to the relay, which is under here. Oh, that's it. The numbers on mine are upside down. It just pulls right out, straight out, pull it straight back towards the dash, and it'll come right out of that socket. Okay, we've got the relay apart. It just slides right out. Pry it out from the bottom, no problem. Now, I've already found 2 things wrong with this. The first thing is an unidentified, in other words, there's no board reference, but there's a little 47 mic 25 volt capacitor. It's in my hand here at this spot. Now the polarity is not marked, so you notice I put a black dot here indicating negative. So why did I pull this? Well, the first thing, in order to see what might be wrong with this part, you need an ESR meter. So here's my Bob Parker ESR meter. And there's a scale on the meter. So if we look up 47 microfarad right here, and we come across the 25 volts right here, you see that the maximum resistance for this capacitor is 1.2 ohms. All right, let's see what this one tests. Now the nice part about these ESR meters, at least this Bob Parker model, this is the original. There's a little bit newer one now that looks different. So the nice thing about this is you can do it in circuit, and this is what was flagged. And you put the probes on it, and right at the moment it's reading 2.1, was a little bit higher in 2.2. See, it's changing. A little bit higher in circuit. Now, you might not think that that's a big deal, because 47, 25 is supposed to be 1.2 ohms, but that's 2.2. So that's, you do the math, that's an ohm higher. That's 50% error. So it's 50% off value. Now, is that going to be enough to cause this module to malfunction? I don't know, but I'm sure going to change it, and we're going to find out. So that's why this part was pulled. What's it worth? I don't know, 10 cents. We're going to change it. Now, the next thing that I found wrong with this, and I don't know if I can show it to you here. By the way, there's hardly any parts on here. So you have a few resistors. They all check fine. You have some diodes here. They check fine. And these two, everything's fine. Except these are the solder joints that join the circuit board to the contacts. So it looks fine, but if you look at it through high power magnification, I don't know if we can do this. Every one of these connectors has cracked solder joints. Very, very hard to do. Sometimes even when it's clearly illustrated, people cannot see what you're talking about. There's one right there. That one's pretty much cracked all the way around. but every single one of these has cracked solder, especially on the bottom part of the connector. There's a couple in the middle that are cracked all the way around. So yeah, that could cause it, especially on a hot day or a cold day. Heat expands, cold contracts. You get a higher resistance contact or maybe a wide open contact. It's just not working. So those are the two things that I find. And we'll see if that's going to fix my problem. I have nothing to lose. It's already broken. Here's a little more information on this capacitor. I'm just about to grab one from my stock. I noticed that it's marked 85 degrees. 85-degree capacitors are nothing but trouble. Well, as luck would have it, I'm out of 47 microfarad 25 volt. But you can substitute a higher voltage. Remember, this is only a 12 volt car. So we're going to substitute 35 volt, 47 microfarad, 105 degree. Physical size, it's just a little bigger, but there's plenty of room in there. It's the same height. They're going to fit fine. So we'll use one of those. Now, before we put it in, let's just check ESR. .58. So that's definitely going to work for us. We'll put it in and see how we make out. So in case you're wondering about capacitance, I have it connected here with these alligator clips. And 47 microfarad reads pretty much right on the money. Now let's look at the old one. So it reads 50.6 microfarad. That's in range. So if all you had was a capacitor meter, you'd think this cap was okay. And so that's why ESR meter is what you really need to find bad capacitors. So we've applied some solder. It's a little crooked. And we'll straighten that out with the desoldering tool. I'm just pressing down on the top of the cap. Desoldering tool gets a nice flow. That's pretty good. Now we're going to use the desoldering tool also on these connectors. So what I like to do is vacuum off the cracked solder, because you can't trust it and you don't want to mix it. So you add a little fresh solder. So that's how you do it. You add fresh solder. Let the tool pick up the whole mess, and then resolder. Okay. I now see nice, clean, shiny joints. No cracks. Will it make a difference? Well, it's going to work better. Will it solve the problem? We're going to find out. Now, here's the final step. isopropyl alcohol. I just have it in a little bottle. This is rubbing alcohol. Maybe a little stronger, probably 90%. But you can use rubbing alcohol. So I'm just going to put some isopropyl alcohol on the areas that I soldered. Then I'm going to take an old toothbrush, just clean off the flux. Not everyone does this. I like to do it because then it makes the board look factory fresh. You don't see any evidence of rework. More professional job. Now the white mark that you see in the lower left corner is to help you put it in so you don't put it in backwards. Now let's put the fuse back in and see if we fixed it. Wipers are off. They're not running, but let's see if they still run. Okay, here's intermittent. Here's slow. Here's fast. Alright, we'll go back down. This is a single swipe if you push down. Let's see, this would be washer. So it would appear to be fixed and working perfectly. The main problem, I would say, were the cracked solder joints where the connectors were soldered to the printed circuit board. As far as the cap goes, that was probably timing for the intermittent. So we'll see.